Heart rates, estimating with confidence. Do you know your heart rate? Could you take your pulse? Today we're going to consider the heart rates for women and the heart rates for men, and ask ourselves, are they different? We'll begin with two samples, a sample of female heart rates and a sample of male heart rates. If we summarize the data using tables, graphs, and numbers, we do see that the mean heart rate amongst women is higher. So is there evidence to support this? Well, first let's begin with the central limit theorem. And it states, suppose that the distribution of a variable has a mean mu and a standard deviation sigma. Then for a sufficiently large sample size n, let's say n is greater than or equal to 30, our samples of men and women are each 40. So we can assume that the sample mean or sample means of all simple random samples of size n will be normally distributed with the mean and standard deviation as below. The mean of the sample means is going to be equal to the mean of the population. And the standard deviation of the sample means will be equal to the standard deviation of the population divided by the square root of the sample size. So for instance, if we consider this normal distribution centered at the mean of the population, if we go two standard deviations left and right, this is an interval in which approximately 95% of all the values lie. If we want to be a little more precise, it's not exactly two standard deviations, it's actually 1.96 standard deviations left and right of center. And so if we're looking at confidence and confidence intervals, we have the formula here at the bottom of the screen. We're trying to estimate mu there in the center. So if we took a sample and computed a sample mean, for instance, we might get an x bar that is close to the mean. In this case, since we're going to go 1.96 standard deviations in both directions to construct our interval, the result is an interval that actually does contain mu, the population mean. Another example of this is if we took another sample and found a separate sample mean x bar, we could go 1.96 standard deviations left and right of this point estimate x bar, and in this case, the mean does lie in the interval, although toward the very end on the left. Both of these intervals were within 1.96 standard deviations of the mean itself. And so when we created the interval going both left and right, 1.96 standard deviations, that was sufficient to actually include the mean in the interval. Another scenario would be a sample mean in which x bar is further away than indicated in our formula. So when we created our interval, it did not extend left and right far enough to include the mean. It's important to note that 95% of all samples will result with sample means x bar within this red range. However, 5% of all samples will be like the red interval here and will not actually include the mean that we're trying to estimate. And this is what is meant by 95% confidence. So considering our data, notice that we had two samples of size 40. And because this was sample data, we don't have the population standard deviation sigma. We have the sample standard deviation s. So in this case, we're going to adapt and use another formula using the t distribution as given below. Notice it is very similar to the other. It's just now we're estimating sigma using s. So if we were going to calculate these intervals, so for the male pulse rates, we have a sample mean of 67.25 beats per minute. And for the female pulse rates, we have a sample mean of 77.5 beats per minute. So if we actually construct the interval for the female heart rates, we end up with an interval between 73.8 and 81.2. If we construct an interval for the male heart rates, we end up with an interval between 63.9 and 70.5. And so each of these intervals represents our best guesses at the mean heart rates for each of the two populations. And since they share no outcomes in common, it leads us to believe that, in general, and with confidence, we state that the mean heart rate of women exceeds the mean heart rate of men. A natural question we could ask ourselves is, why is the mean heart rate among women greater than the mean heart rate among men?